Hi students, I'm going to go ahead and hopefully help you review some algebra today. This is Unit 5 and Day 1, Review and Ramp Up. So welcome back to the new semester. I'm sorry I'm not there with you today. Just please remember everyone is starting fresh, brand new for semester 2. So everyone is doing amazing at this point. And we want to make sure we try to do the best we can to stay on top of things. So please set goals for yourself. Make sure that you have focused time to watch the videos and take good notes. Make sure you're asking questions. Always use your mistakes as information. Plan to attend flexes and students for success. And then also please try to sit with that discomfort of being in the pit. That's how you're going to continue to learn and grow. All right, there is a slight hiccup, and I know I sound a little weird. I actually have COVID right now, and I won't be allowed back on campus until January 11th. So we are just going to do the best that we can, and I'll be providing you with videos to hopefully help you stay on top of things, and then I can support you better when I'm back in person. So please make sure you watch the videos, take those good notes, document all your questions. This might be a good time to use different colors or sticky notes or something to make sure that you're not losing track of things when confusion is there. Work together and help each other, and of course, stay healthy. If you're not feeling well, please make sure that you are staying home. Okay, so the agenda for today is you will be looking at your semester 1 scores and making sure everything is correct. Now, I changed semester 1 to this kind of lame picture. The learning pit picture is semester 2 now. So you're going to actually see 2 courses of pre-calc and all your other courses. So your dashboard is going to be really messy. So please make sure you know which course you're clicking on. So you're going to click on this purple one. Look at all your semester 1 scores. If there's any issues, if there's something that you didn't resubmit and I had a comment for you to resubmit it, something like that, you're going to reach out, let me know so that we could clean the gradebook up. The next thing you're going to do is you're going to do a review day to sharpen your algebra skills. And then you're going to begin working on homework 5.1 in your packet and sign up for a new Delta Math and do a little bit of work in there as well. Okay, so again, checking semester 1 grade, you're looking at this boring purple math icon. That is semester 1. You're going to view each grade and report any issues using the Google form. This is a Google form here, and you're going to go ahead and click on that to report any issues that you have. Every retake that you have taken should have a comment. It'll say score before retake was blah. Even if it didn't improve, I should say something there saying, retake score was same score. If you have a retake that you did and there's no comment, that is likely meaning that the score has not been entered. So I just want to make sure you look at your own grade report. Make sure everything has been updated. It's never my intent not to update a score, so please just double check for me to make sure everything looks good. If you had turned in homework and it wasn't graded, let me know. I think I've combed through everything with that, and I think we're okay. Also, if Mr. Grossman or I wrote a comment and you did not respond to that comment, if we said something like, oh, I can't read your rescan it, and you didn't do that, you should see those comments. If you need to do that, please do it, but please let me know. I won't be going through every single bit of every single person's grade. So you're going to have to tell me with the Google form, Mrs. Wojcik, I missed a comment on homework 1.2. Could you please go back in and grade it? Okay, so you can pause the video, go ahead, take time to do that, and submit that Google form. And then when you're ready, we're going to go ahead and do some algebra reviewing. Please make sure you take little breaks from this. You can pause me, try to do some of the problem, and then go ahead and listen again to how I did it. But I'm really going to focus in on the process. It's really important that you're solid on these skills. So when we move forward with some of the messier solving, you'll be right on track. So this should be reviewing Algebra 1 and 2 solving steps. Okay, so Question 1. Hopefully you remember the do and undo structure. So we had something that said do with X, and then the undo was here. So we ask ourselves, what was done to X first? And already I'm out of space because I made this a pretty big problem. All right. So the first thing was we subtract 5. Then we multiply by a -7. Then we add 2. And then the last thing is we divide by 2. So the first step is closest to the X here. Look inside the parentheses. Then we look at what's being multiplied, and we know it's actually multiplied by a -7 because you can add the opposite there. The next thing being done is this +2, which is a +2, and then divide by 2. So those are all the things that were done to X. And I'm reviewing this. Hopefully you've seen this before in Algebra 1 and 2. And it's not something you have to use this structure, but I just want to show you how we undo to isolate. So the undo steps, what we're going to do is the last thing that was done, which is divide by 2 right here, we're going to do the inverse operation. So we multiply both sides by 2. This is the undo steps. We multiply by 2. Then, how do I undo adding 2? Oh, I subtract 2 from both sides. How do I undo multiplying by -7? I divide by -7. And how do I undo subtract 5? I add 5. And when all is said and done, we should have the variable isolated, which is the ultimate goal. So all I'm going to do is I'm going to take these undo steps and I'm going to show you how I'm doing them. So I want to multiply both sides by 2 first. We have a 2 in the numerator and denominator. We're allowed to cancel that. So 2 minus 7 times the quantity x minus 5 equals 16. I then am subtracting 2 from both sides. That cancels. I'm then going to go ahead and divide both sides by a -7. So x minus 5 equals -2. And I add 5 to both sides. So x equals 3. And that's your final solution. Now, we always want to check our solutions. And some of you are going to kind of resist that. I'm going to ask you to really at least do it mentally, plugging it in. But to check a solution, all we're going to do is replace the x with what the solution is, this 3. And we're going to make sure we get a true statement. So 3 take away 5 is -2. And remember, it has to equal 8 when I'm said and done here. So we do order of operations. We're going to do that multiplication first. So 2 plus 14 over 2. And that's 16 over 2, which is 8 equals 8. And that means what we have here, 3, is the solution. Okay. I showed you on all these. You don't have to copy this graph down, but I want to mention a couple of things. First of all, if I were to move everything to one side, and you don't have to write this down if you don't want to, and if I set it equal to y to create a function, in the original problem, there's only an x. We're just isolating x. If I wanted to write this as a function and then graph it, here's what we're going to see, an x-intercept at 3, 0. That's the solution we found, x equals 3. So that's another way to verify your solution, is if we created this to be a function, the x-intercept would actually match the solution you found. I want to mention a couple of other things here real quick. And these are some common mistakes I see. Sometimes I'll see this. And then people will go ahead and just kind of keep chugging along. If you were to do this, we divide both sides by -7 and add 5. It'll be messy. 5 take away 8/7, whatever that is. If you were to plug that in for x, you're going to find out right away that is not a true statement. This equation, the original one, is not saying 2 divided by 2. It's saying this entire numerator divided by 2. So that's a real common mistake that I see. I'm going to show you one more mistake that I see. And I'm just going to cross that out. People are very tempted to go ahead and do the subtraction. And then they say, okay, negative 5 times x minus 5 over 2 equals 8. And then they start solving. That's not what this is saying up here. This is saying 2 minus a product. Order of operations. That product has to go first. Remember your order of operations, Gemma? This is for grouping. This is for exponents. Multiply and divide in the order from left to right that they appear. And this is add and subtract in the order they appear from left to right. We always have to follow those order of operations. Okay, so we're going to start reviewing some quadratic solving. Now we know these are quadratic equations because the degree is 2. So anytime we have a degree of 2, we have a quadratic. Now, the thing about quadratics then is that we have a potential of 2 real solutions. The number of solutions will be equivalent to the degree. They might not all be real solutions, and we'll get into that a little bit. So one of the things we can do here, again, undoing the thing furthest from x, is we can isolate that squared term. And so now I'm going to go ahead and divide both sides by 5. Remember, get the x squared. We want to get the squared term, that squared alone. So I can go ahead and get this x squared equals negative 4/5. Now, to get x alone, we'd have to take the square root of both sides. This number is negative. So if I take the square root of both sides, I'm going to get x equals plus or minus the square root of negative 4/5. This means no real solution. No real solution. This is an imaginary solution. I'm not sure if you remember the square root of negative 1 is the imaginary unit I. You don't have to do anything with this at this point. You do need to make sure you have a plus or minus anytime we take the square root of both sides. There are 2 answers for that. And for example, if we had x squared equals 9, we know there's 2 things. If I square them, that will give me 9. 3 squared is 9, and negative 3 in parentheses squared is also 9. So when you take the square root of both sides of an equation, you have to remember that plus minus. Now let's look at this next one and do the same thing. Now, some of you might want to expand this. There are certain times that might be helpful. In this one, I think if we just subtract 6 from both sides, we're going to actually be in pretty good shape. So if I subtract 6 here, we'll get 36. I'm going to take the square root of both sides. And so the square root of a square, that undoes the square. So x minus 3 equals, don't forget the plus minus, 6. Now I need to add 3 to both sides. Now this is where you got to be a little careful because we have a positive 6 and a negative 6. So your answers will be 9 and negative 3. Because it's 6 plus 3, that's your 9, and negative 6 plus 3, that's your negative 3. Now, again, we want to plug this in to make sure that everything works. So if I plug in a 9, 9 take away 3 is 6, square it is 36, plus 6 is 42. Okay, so that checked out. If I put a negative 3 in, I get a negative 6. Quantity squared is still 36, plus 6 is 42. So both of those are solutions. Now let's take a look at each of these quadratics as a graph. And again, you don't have to copy the graphs down, but let's take a look here. Let's see. So I already know that I did something wrong on this one. I think I clipped in the wrong, I totally did, the wrong picture here. Okay, so let's see if I can fix this. So we have 5x squared plus 4 equals y. And for this, we'd have 1, 2, 3, 4 here. And it would open up and be pretty steep. Okay, sorry. So that's the picture we should have for this one. And I'll update the slides, but for the video here, it's going to be different. Notice there are no x-intercepts. And we said here, no real solutions. So in this case, it's a parabola that opens up and it's above the x-axis. It will never intersect. Now this next one, we had the -3 and the +9. Let me make sure that's correct. Yes, it is. So when you graph this, it intersects the x-axis twice. And again, for each of these, if you were to write this as an equation, all I did was I moved everything to one side and set it equal to y. Be the same thing up here. We could just subtract 42 from both sides. And then we would say for this one, it would be y equals m-3 squared minus 36. And we would be able to graph that equation. Okay, so it's not asking you to graph. I just want you to look at the connection between the function and solving the equation. All right, let's try this next one. So this one I already know, again, it's quadratic. So I'd like to see, here's a mistake I see. Okay, so with this one, I see people try to do this, take the square root of both sides. Good instinct, because you're trying to undo the square. But that's not going to look, this is a legal move to do. But first of all, the only thing that could come out is the x squared, because it's perfect. This has to stay underneath. And this whole thing is not perfect, so that has to stay under the radical. So in terms of getting x alone, that's not helpful. Instead, let's go ahead and put everything in standard form. So I'm going to move everything to the left because I really love, if I can, to keep my leading coefficient positive. I just prefer it that way. Okay. So from here, we can look at this and see how to solve. So we have a few choices here. Taking the square roots of both sides is not going to work in this case. That's going to be pretty messy. It's not going to be helpful. So another tool we can use is factoring. So with factoring, we can put that first term here, 2x squared, the minus 35 down here, and then remembering the diagonal is going to be that middle term, 9x, negative 9x rather. Okay, so I know a 2x and an x, because those are, in my choices to get to be 2x squared would be x times 2x. And then for negative 35, I can do a negative 5 and 7. So let's try negative 5 and 7. That's a negative 5x here because it's negative 5 times x. And 2x times 7 is 14x. That gives me a positive 9x for the diagonal. So that means I'm super close. So when you do this and you're kind of guessing and checking, don't kind of scrap everything. If you're that close, we can just tweak a couple things, and now we're good. So we would say this factors into 2x plus 5 times x minus 7, and that equals 0. So what we did is we wrote this trinomial as a product. Now, how does that help me? If two things multiplied together equals 0, one of those things, one of those factors, has to be 0. That's the only way. So we have ZPP, which is the 0 product property. Okay, so 0 product property, what we're going to do is we're going to set each of those factors equal to 0 and solve. So 2x equals negative 5, x equals negative 5 halves, and x equals 7. These would be my two solutions. Now again, you're going to substitute those in for x, and you're going to evaluate to make sure you get a true statement. If you plug those in and you don't get a true statement, there's a mistake somewhere or it's just not a solution. So negative 2.5, negative 5 halves, and 7. If we look here and we were to graph that, if we set it equal to y, again, we would move everything over and then we'd say y equals 2x squared minus 9x minus 35. This is the picture of the parabola, the quadratic, and those are my x-intercepts. Again, not asking you to graph at all at this point, just showing you the connection between the function and between solving. Okay, now for this one, if we try to factor this, again, it's a quadratic like we've been doing, right? We have 10k squared and 1, and this is supposed to be negative 6k. So for the 1, the only thing I can do is a 1 and a 1, or they could both be negative 1s. That would work as well. And for 10, we have 1 times 10 and 2 times 5. This is not going to be able to be factored the way that we know. So what I'm going to say now is we need to use that quadratic formula. So quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. And when I start feeling better, you better believe I'll sing it to you. But right now, I'm trying not to cough. So in order to use this, we have to get our equation in standard form. The a is always with the squared term, the b is always with the term to the first power, and the c is the constant. So let's solve this using that. K equals, that's the variable I'm solving for k. I want to know what is k. The opposite of b, this is your b value, this is c, and this is a. Opposite of b, plus or minus, b squared. Please make sure you have those parentheses. That's very important. Minus 4 times a, that's 10, times c. All over 2 times the a value. Okay. So we have 6 plus or minus 36 minus 40 all over 20. We continue to solve. K equals 6 plus or minus square root of negative 4 all over 20. Now, you can leave it at this point and say no real solution. There are actually 2 imaginary solutions. For those of you who remember the imaginary units, it becomes 2i because the square root of 4 is 2. And the square root of negative 1 is I. So that's my 2i all over 20. Now another mistake I see, and I think this is similar to the other slide I showed you, people get all cancel crazy and they cancel maybe these 2. That's not correct. 20 is the denominator of this. Now what you can do is a little math is love thing. You could take each term and divide it by 20. That would be fine. So that would be 6 over 20 plus or minus 2i over 20. And then, of course, you can reduce the fraction. So it would be k equals 6 over 20 is 3/10 plus or minus I over 10. This is fine at this point to stop here, okay? But you might need to use the quadratic formula. There's times where you won't be able to factor or take the square root of both sides. Okay, and so we see that there was 2 imaginary solutions. Notice there are no x-intercepts. And that's how we know we are definitely going to have imaginary solutions. Okay, if you have not taken a little break, please do that. I know this is a lot of talking at you, which I'm not a big fan of. But since I'm not here, we're going to have to do the best we can. To undo that squared term, or the square root, I'm going to square each side. Again, we must do it to both sides. So to undo a square root, we square, and so we just have x plus 12 equals x squared. Now we have a quadratic equation to solve. I can't just take the square root of both sides. First of all, if we did that, you'd end right here where you started. So you'll know right away, like, oh, that just undid the thing I was trying to find. So instead, I'm going to get everything over to the right side. I prefer the leading coefficient, in this case 1, to be positive. I just like to work with that better. There's nothing wrong with having a negative leading coefficient. So either way is fine. All right, so from here, we're going to go ahead and factor. So I have x minus 4 times x plus 3. And if I have a product equal to 0, I can use ZPP, the zero product property. X minus 4 is 0, or x plus 3 is 0. So we get 4 and negative 3. All right, let's test this. So let's test 4. That would be the square root of 4 plus 12 has to equal 4. Square root of 16 has to equal 4, and 4 does equal 4, so that checks out perfect. Let's put in negative 3. Negative 3 plus 12 under the radical has to equal negative 3. So this is the square root of 9 has to equal negative 3. 3 has to equal negative 3. Well, that's obviously not correct. We call this an extraneous solution. We didn't do any math wrong, but it does not work when we plug it back in here for x. So this has one solution, and one solution that is extraneous. And you see this graph, this is some kind of like little weird loop kind of graph here when you look at this with the square root. And really it would be the square root of x plus 12 minus x. So still a function, but a little, different than what we've looked at. But you can see it only crosses the x-axis one time. All right, let's look at a cube. So again, get that x cubed alone if possible. There's no other variable in this, so I would just right away isolate. So we get 32, we divide both sides by 4, and we get 8. And now how do you undo a cube? You take the cube root. The cube root of a perfect cube is just that, x. And what times itself 3 times is 8? That's 2. Now some of you are going to get a little plus minus crazy here. There's no plus minus when we take an odd root of both sides. Because if we think about it, if we had negative 2 to the third power, that's negative 2 times negative 2 times negative 2. That's negative 8, not positive 8. So odd roots, you will have one answer, either positive or negative. Even roots will have 2 answers. And we see this cube, and here's where it crosses at the 2, 0. Okay, now this is something that we really need to focus on, directions. When I ask you to solve, I want you to isolate the variable. Isolate the variable. When I ask you to factor, I want you to write expression as a product. There is no equal sign here. You cannot get x alone. When there's an equal sign, this is when you can do operations to both sides and you can isolate that variable. So let's look at the factoring one. This would be x minus 5 times x plus 2 and done. That is now written as a product. Now over here it's the same trinomial, but it's an equation. So I could say it's x minus 5 times x plus 2, and that product is 0. This is when we go with our ZPP. So x minus 5 is 0, x plus 2 is 0. And those are my 2 answers. Again, always plug in to check. There's no checking to do with factoring. There's nothing to plug in because you didn't isolate the variable. Anytime it says solve, isolate the variable. Okay, so quick little summary here. You're going to isolate, here's your tools for the quadratic. So if you see a quadratic, isolate the squared term, take the square root of both sides. Remember, if you take an even root of both sides, plus minus. You can also factor and use ZPP, and you can use the quadratic formula. You should get the same answer with whichever tool you use. Make sure you can use the tool, obviously. If you can't factor it, then you're not going to use the factoring tool. Okay, now, trig is not going away, so we want to make sure that we do a quick little review with this too. So for this one, 4 cosine of theta, take away cosine theta. Well, that would leave us with 3 cosine theta. That's just combining like terms. Isolate the cosine. So we're going to divide both sides by 3. And you're going to end up getting negative 1/2. Now, cosine of theta is negative 1/2. Your goal is to tell me what is theta. I want to know what angle, if I plug it in, will give me negative 1/2. So let's think of our special right triangles. Cosine is adjacent, and the adjacent angle here for 1/2 is going to be that pi over 3. So my reference angle is pi over 3. Now, what quadrants has cosine as negative? Well, x is negative here and here. All right? So we think, okay, reference angle is 1/3. So this is going to be at 2/3 pi. And right here at 4/3 pi. So you're going to say, as your answer, you're going to have to say theta equals, just like you did x equals and m equals. Get the variable isolated. Theta is 2/3 pi plus 2 pi k, because we didn't have any restrictions on the domain. And theta is 4/3 pi plus 2 pi k. This is when k is any integer. Okay, now looking at this on a graph, here's the 2/3 pi, here's the 4/3 pi. You want to know all the times this is going to happen. So if I add 2 pi to this, boom, I'm here. And if I add 2 pi to this, boom, I'm here. We could subtract 2 pi. That's why we have the infinite number of solutions. That's every time this crosses the x-axis, if we were to write it as a function. Again, a function then would be 4 cosine theta minus cosine theta plus 1.5 if we moved everything to one side and set it equal to y. So if you're messing around with Desmos and you want to try to plug it in, that's what you would do. Okay, I think, yes, this is the last slide here. Or last problem we're going to do together. Just a quick reminder about function notation. So if I give you a function, g of x, this is the function g, this tells me the input. So g of x is the same as saying y equals, but it gives you more information. And now we're saying, hey, evaluate. I want to know, when I plug in, when I substitute 6, what do I get? You'll write the original function with 6 in place of x. So in this case, we would get 3/4 pi. So let's think about where 3/4 pi is. It's right here. That's your pi over 4, right? So this is 3/4 pi. And sign is positive up here. And we know the legs are both radical 2/2. So this would be 2 times radical 2/2. Of course, we can go ahead and do some canceling here. And g of 6 is radical 2. Okay, so I don't know how much time you have left in class, but I'd like you to at least save the last 15 to 20 minutes to work on homework 5.1. I'm hoping the packets are near the door on the counter. If they're not there, I did post a PDF in semester 2 pre-calc. Okay, it's got the learning pit. That's the picture you click on. Okay, you could just write it on your own paper. You don't have to rewrite it later when you get the packet. I don't care as long as you're doing the problems. Don't do problem 5 yet because I haven't taught that to you. But everything else, not saying they're all easy, but you should have the tools to be able to do those problems. Don't forget to check all your solutions. Plug in the answer. Make sure it's a solution. Read directions carefully, especially when it says factor versus solve. Okay, if you have time beyond 15 to 20 minutes, I would love for you to use this Delta Math link for you to get some extra practice. I selected different problems from Algebra as a review for you. Delta Math is pretty nice. It usually leads you through examples and kind of helps you with different step-by-step instructions. Please make sure you're keeping track of any questions that you have, okay? Highlight your notes, whatever you need to do so that you get those things in. Okay, so you're going to, I guess this is step 1/2. Upload your notes, okay? Upload the notes for me. That's written as an assignment, so you'll see it in your upcoming in, again, this semester 2. Upload the notes you just took. If you only have 15 or 20 minutes, just work on the homework. If you have more time than that, then go ahead and get started on Delta Math for a little bit, just to pick and choose some extra problems to try. Okay, I hope you guys are doing good. I will be uploading more videos for you. Sorry about my scratchy voice. And